A very good morning and warm welcome to the video classes. Dear students, I have given you notes, or let us first ask you how you all are. Hope you all are fine and fit. I've gone through your copies. I was very happy to see that most of you have written what was given in the class or what was shared in the video classes, and I have also corrected your copies. I am very happy with your performance. Now I am going to discuss about the chapter metals and non-metals. Already I have given you notes and videos, send you videos about the metals. Today I am going to start off with my discussion with the non-metals. Today I am going to start the discussion with non-metals. So, non-metals are electronegative in nature. I will be starting off with the chemical properties. Already physical properties I have told you. Chemical properties. Non-metals, what are the physical properties? Physical properties, they are non-ductile, non-malleable, they are brittle, they are non-sonorous, they are mainly solid, liquid and gases. The first property is electronegative character. First property of non-metal is electronegative. Okay, first property. Now, non-metals are generally electronegative in nature. It have a tendency to accept electrons and form negatively charged ions. It have a tendency to accept, because if you take chlorine atom, Ca, it has got 17 electrons. To become stable, it takes an electron and forms Cl minus. This is called as chloride ion. Chloride ion. Okay. Like that, oxygen, it has got 8 electrons. If it accepts 2 electrons, it forms 2 ions. That means oxide ion. So you saw chlorine, chloride ion and oxide ion. Now non-metals are able to remove electrons from electronegative elements, and they acts as an oxidizing agent. They acts as an oxidizing agent. Clear? Now hydrogen is the only non-metal which can lose or gain electrons. It can lose or gain electrons. Like hydrogen, when it gains electrons, it forms hydride ion. Hydrogen, when it gains an electrons, it forms H minus. We call it as hydride ion. We call it as hydride ion. And when it loses an electron, then it forms hydrogen ion. When it loses an electron, then it forms a hydrogen ion. Clear? Now, so this is hydride ion is an ion, and this is a cation. So this much is clear to you. Any doubts you can ask in my class. Okay. Anything which you don't understand, please, once I put the videos notes, you can ring me back. Now carbon, they are as a non-metal. They are also reducing agent. Acidic oxides. Carbon, these are all non-metals, forms non-metallic oxide or acidic oxide, which turns blue litmus paper to red. Now, there are 5 main air pollutants present as oxides of non-metal, like carbon monoxide, nitrogen oxide, nitrogen dioxide, and sulfur dioxide, and carbon dioxide also. Next, and this one sometimes they act as oxidizing as well as this hydrogen, they act as oxidizing as well as reducing agent, my dear student. They act as oxidizing as well as reducing agent. Next is reaction with oxygen. reaction with oxygen. Now non-metals reacts with oxygen to form non-metallic oxides. Non-metals reacts with oxygen to form non-metallic oxide. Okay, like a non-metallic oxide, when dissolved in water, they form acids. Okay, now which turns blue litmus paper to red. Now nitrogen reacts with oxygen under different conditions to form different types of oxide, like N2, 2N2 plus O2. It forms 2N2O. This is nitrous oxide. This is nitrous oxide, which is a neutral in nature. Which is neutral in nature. N2 plus O2. N2 plus O2, it forms 2NO. It is nitric oxide. It is nitric oxide, which is also neutral in nature. Now 2N2 plus 3O2, it forms 2N2O3, dinitrogen oxide. Dinitrogen oxide. This is acidic in nature. This is acidic in nature. This is acidic in nature. Next, another one is N2 plus 2O2. N2 plus 2A2, it forms 2NO2. It forms nitrogen dioxide. It forms nitrogen dioxide, which is also acidic in nature. Now, this nitrogen, when reacts with 5 molecules of oxygen, last class I told you about that, about the different nitrogen reaction of nitrogen with different oxygens. Like when N2 reacts with O2, it forms 2NO2O, that is called nitrous oxide, which is neutral in nature. N2 plus O2, 2NO, that is called as nitric oxide, which is also neutral in nature. N2 plus 3O2, dinitrogen trioxide, which is acidic in nature. N2 plus 2O2, 2NO2, that is nitrogen dioxide. N2 plus 2N2 plus 5O2, it forms nitrogen pentoxide, which is acidic. This is dinitrogen pentoxide. Pentoxide, which is acidic in nature. N2O5, when it reacts with water, it forms 2HNO3. It forms nitric acid. It forms nitric acid. Is it clear, students? It forms nitric acid. Next, if you coming with carbon, when it reacts with carbon reacts with oxygen to form 2 oxides. One is carbon monoxide, another is carbon dioxide. Carbon monoxide is neutral in nature, whereas carbon dioxide is acidic in nature. When this carbon dioxide dissolves in water, it forms carbonic acid. Now, this carbon monoxide is a very poisonous gas, because if you inhale too much of carbon monoxide, it reacts with the blood or the oxygen present in the blood to form a very poisonous substance, that is oxyhemoglobin, which hinders the supply of oxygen into the blood, and that leads to the suffocation and persons also die. So when carbon reacts with oxygen, this is limited amount, it forms 2CO. This is carbon monoxide. Okay. When it reacts with carbon dioxide excess, this forms carbon dioxide. When this carbon dioxide is put in water, dissolves in water, it forms H2CO3, which is called as carbonic acid. This is a very weak acid which turns blue litmus paper to red litmus paper. Is it clear, students? Next is with same thing with phosphorus. Phosphorus also reacts with two oxygen to form phosphorus trioxide and phosphorus pentoxide. Both are acidic in nature. If it comes with phosphorus, 4p plus 3O2, it forms 2p2O3, phosphorus trioxide. And when it reacts with 4p plus 5O2, it forms P2O5, phosphorus pentoxide. These both are acidic in nature because P2O5, when it reacts with water, it forms H3PO4, which is phosphoric acid. It is phosphoric acid. That is, it is phosphoric acid. This is phosphoric acid. Next is with sulfur. Same thing, sulfur burns in air to form two oxides, that is sulfur dioxide and also as sulfur trioxide. Sulfur dioxide, when it's sulfur trioxide, when it's dissolved in water, it forms sulfuric acid. Okay, same thing, like this is with sulfur. Sulfur S plus O2, it forms SO2. 2S plus 2O2, 2SO2. Or 2S plus 3O2, it forms 2SO3. This is sulfur dioxide. This is sulfur trioxide. SO3 plus H2O, it forms H2SO. It forms sulfuric acid. It forms sulfuric acid. So this is limited, this is excess. This is limited, this is excess. Same thing with hydrogen, reacts with oxygen to form water, which is neutral in nature. Next is with reaction with halogens. Next is the reaction with halogens. Reaction with halogens. Now reaction with halogens. Reaction with halogens. Now phosphorus reacts with chlorine to form phosphorus trichloride, or if it reacts with chlorine in excess amount, then it forms phosphorus pentachloride. That is 2p plus 3Cl2, it forms 2PCl3. 2p plus 5Cl2, PCl5. It forms phosphorus trichloride, phosphorus pentachloride. Okay, in presence of the sunlight, in presence of heat, and this is also heat. Sulfur also reacts with fluorine at higher temperature to form sulfur hexachloride. Now next is the reaction with hydrogen. Okay. Sorry. Non-metals reacts with hydrogen to form covalent hydrides. Non-metals reacts with hydrogen to form covalent hydrides. Like they do not conduct electricity, that they may be acidic, they may be basic, or they may be neutral. Like H2 plus S, H2 plus S, H2S. Okay. H2 plus S, it is H2S. Next is N2 plus 3H, N2 plus 3H2, it forms 2NH3. This is ammonia. This is ammonia, this is weakly acidic. Weakly acidic. And H2 plus O2 forms 2H2. Okay, it forms 2H2O by doing electrolysis, electric spark. This is. Now, there are reactions with acids. Acids, they do not react so much with acids. Okay. Now, reaction non-metal do not displace hydrogen from dilute acids because they are not able to give electron for reduction. Exception is there when sulfur reacts with nitric acid. When sulfur reacts with nitric acid, it forms sulfuric acid, nitrogen dioxide and water. S plus 6HNO3, it forms H2SO4 plus NO2 plus H2, 6NO2 plus H2, 2H2. This is the thing. Now, next is the displacement reaction. Certain non-metals, non-reactive metals, they displace less reactive metals from its salt solution. For example, potassium bromide displaces chlorine, certain more reactive metal displaces less reactive metals from its salt solution. Like 2KBr, potassium bromide displaces chlorine to form 2KCl plus Br. This is the displacement reaction. This you term it as displacement reaction. Fine. Now, or potassium iodide reacts with chlorine to form potassium chloride and iron. Now, students, in your copy, in page number 73, there is a comparative study between metal and non-metal that you have to write in your copy. Okay. Now, what is the chemical properties? Metals, they form metallic oxide or basic oxide, whereas non-metal, they form acidic oxide or non-metallic oxide. They react with water like sodium. They do not react with water, non-metal. Metals reacts with acids to form metal salt and liberate hydrogen gas, whereas also they do not displace. Like this you have to go through. Now, oxides of metals and non-metals. Like I have told you, oxides of metals and non-metals, like metal oxides, they react with oxygen to form metal salt. Like when you magnesium ribbon, if you take a magnesium ribbon, you just wipe it with sand paper. Now when you burn it with the help by holding it with the tongue, it will burn with a white dazzling flame. When it burns, magnesium burns, it will form magnesium oxide. When that magnesium oxide ash, white ash is put in water, it will form magnesium hydroxide. How will you know it is a base? If you put red litmus paper, that color will change to blue. Similarly, with non-metallic oxide, they react with acids to form non-metallic oxides, or which turns blue litmus paper to red. Like sulfur, they react with oxygen to form sulfur oxide, which further reacts with water to form sulfuric acid or acidic in nature. Same thing. Now there are certain uses of metals, like iron, they are used for making bridges, engine parts, steels. Coppers, they are used for making electrical wire, utensils, coins. Silver for making jewelry, electroplating. Gold for making jewelry, decorative purpose, photography. Mercury in thermometers. Aluminium for aluminium foil, electrical wires, packaging material. Same thing with carbon, it helps in cutting and grinding, like graphite, which is hard for making black lead pencil, sulfur for gunpowder, vulcanization of rubber, chlorine for bleaching powder. Like this, there are certain non-metals. Everything is being provided in the notes. I will upload it. Already I have given you the notes in my last class. Again, I will give you the notes along with the video so that both you can write, both you can see. First watch the video and then see the notes. Whatever doubts you have, you can please ask me. At the end, I have given you some questions to do. Those questions, please students, you do try to do it. And in the next class, I will teach you certain balancing which will help you out to do the balancing. And with this, I finish up the chapter. Only the balancing of equation is left, which I will do in my exam. Thank you. May you have a joyful day.